So hello and welcome to another amazing webinar from our virtual event series at OneAquaHealth project. My name is Alexander Nikolov and I'm working for Senior GmbH based in Vienna, and we are coordinating the dissemination communication work package. The purpose of today's OneAquaHealth webinar is to shift our perspective from nature as a backdrop to nature as the most accomplished engineering system on Earth. Imagine the world's top innovators, no patents, no waste, and 3.8 million years of time. These engineers aren't functional, they are alive in every forest, river, wind, shell, and cell, refining solutions to the longest research and development cycle in history. Over the next 90 minutes, our dear colleague Sona Serra of the Marine Environmental Science Center Aquatic Research Network at the University of Coimbra will guide us through 4 core themes. The program concludes with a resource segment at 5:45, followed by an interactive Q&A session at 6 p.m. and formally closes again at 6:30. So before we continue with our today's agenda, I would like to highlight today's housekeeping rules. Namely, our virtual event will be recorded and posted on OneAquaHealth Open Information Hub in order to ensure, according to the rules of open access scientific information, that all collected insights are openly accessible for all interested parties and can support further development activities in the field. Feel free to ask questions anytime in the chat option. We will do our best to answer them during the event. And if you would like to speak after each presentation, after each slot, please raise your virtual hand. So that being said, I would like to pass the floor to Sonia. Dear Sonia, please feel free to take over the presentation from your end. I'll stop sharing now.
Okay, there we go. I will advance. I will go. Well, Alex already presented me, but I must say that this is not my usual audience. So I'm a freshwater ecologist, and I usually work actually in streams. In particular, I have a specialize in river basins. So what this means in practice is that I pass a long time in the streams and noticing whatever of what no one notices from the stream. So be aware of that and don't get freak out with my ideas. The first challenge I have for you is a question, is in a form of a question where I ask you, and you can leave it in the chat, has any technology we have ever built outperform life itself or nature? This is a question for you. You can write it in chat. Maybe I will leave some time, or I can go on. In the end, we can read it, but you can see. There is no wrong or right answer. Please just leave it in the chat if you think there is any technology that outperformed anything. I think no one. Okay, we can go on. I will be a spoiler. It's very difficult to find such a technology indeed, because the planet has at least 3.8 billion years of research and development with no patents, no waste, and no planned obsolescence. And we should not see technology as something out of the planet, but for the planet and nature is not one solution, is the condition for all solutions. So technology is embedded in the environment. We were created in this planet, and our creations are also creations from this planet. So we should see it as the condition, the planet, the nature, and life is the condition for all the solutions. That's what I want to tell you related to this question. Here I show you what for me, I designed it, sorry, what for me can be a river basin or a drainage basin with smaller streams going through rivers and then to a large river and ultimately to the sea. But depending on your experience and what you are used to see, you can be seeing tree roots, blood vessels, maybe a liver cyst, the kidney, you maybe see a lot of different things that were not intended by me to design. And because this let us know that this same form and the same pattern was reinvented by the evolution again and again. In fact, this says that one form, one pattern, is giving us, is solving some kind of problem. The same, not the same, but more or less a lot of different problems. In biology, we call it convergent ecological convergence or biological convergence. But I like it to believe, I like to call it convergent intelligence. And actually, I like to call it intelligence because I see intelligence occurring in a river basin. When you look to a drainage, an entire catchment, you see that he acts as an information processing network. It integrates a lot of signals. It might be rainfall in the upper streams. It might be dissolving some specific components of the soil. It might be different temperatures in different things. They have a lot of sensors. It works like a big scale network, sensor network. And if we catch the communities, if we do a survey and catch some of their communities, once the presence of a particular larva can tell us more about the water quality than a single chemical test. We will see why, but in fact, life breeds life, and they are the presence of a particular organism will let us know what had happened before. If the organism is, for example, if there are no organisms that breathe oxygen, dissolved oxygen from the water, and just need oxygen from the atmosphere, something is happening inside the water. Probably there is no oxygen dissolved in the water. So this is why there is some intelligence in this process. All this happens with no central processor, so there is intelligence that is distributed, redundant, and context-aware. And one thing that amazes me is that I always learn, I never know enough. I always learn something more about the stream. Sorry. And we go to the part one, where I want to tell you about the illusion of separation. In fact, we are living in an illusion that we are separated from the planet. And there is a story behind this, a dominant story that is here for a long time, maybe from the industrial area, I don't know, some hundreds of years, that technology will liberate us from nature. We will not need the river or the stream anymore and the soil, and that machines will control everything and a lot. Well, this is not just dangerous, but is functionally, it's a problem of functionality. In fact, the reality is that we are embedded in nature. We will never be able to invent or reinvent or build a system like the organic and the ecosystems we have, and we need it to breathe, to drink, to make our body work. And this illusion of separation is not, I don't see it as a liberation, but as a very expensive illusion, because you will see. So we have a dominant story, and I think we all grown up, at least I've grown up with these left side type of diagrams where we see three equal circles, the circle of the economy, of the society, and the environment. They are equal circles, and these give the idea of a balanced diagram. These are Venn diagrams. And then there is a sweet spot, the place where they all overlap, which is the sustainable development sweet spot. And this is one of the problems of the separation illusion. This gives you the idea of a balanced conceptual diagram, but in fact, it's treating the environment as 1/3 of the equation. And fortunately, and when we think, let us think about technology first. When we think about technology, imagine technology, it's very difficult to place here in the dominant story. It's many times it's just in the economy. I was very optimistic in this diagram. I put technology in the sweet spot, but many times it is not. Many technological, well-intentioned technology advances are not in this sweet spot of sustainable development. When you look to the right, this diagram is, for me, the right place to go, unfortunately for many other colleagues, because instead of having 3 circles that overlap, they have 3 different circles with different dimensions, and they are all nested within each other. You have a big one, which is the environment. Then you have the society one. Of course, if we are talking about humanity, so we have the society, the community made by humans, and then you have the economy, and technology is very easy to place. It's inside these nested, this economy circle. This, fortunately, is not academic diagram. This has been, I have a lot of people are working in this shift. This is, I'm sorry for the, this should be nature positive shift, but there was a typo and I wasn't able to fix it on time. This has been a work done by many colleagues, and excellent work done by Locke et al. In this year. And this is not just an academic shift, this is a very important and necessary shift, and you will understand why. Because by disconnecting, when you stay in the Venn diagram with the 3 overlapped circles, you are disconnected from the environment. You are not nested and embedded in the environment, and things happen. And we are seeing things happening like the biodiversity loss. We see the disruption of many ecosystems, including the freshwater ecosystem. There is the climate instability, for example. The thing is, and our species needed stability to develop these big brains, and we were able to live in a relatively stable time. And then we are also inventing novel entities that pose immense, a lot of challenges, because we never evolved with these novel entities. We are talking about nanoplastics, pharmaceuticals, different substance with no evolutionary precedent. So there is no organism that is able to respond to these, and we are not we don't know how to deal with these. I don't know if you already know this planetary boundaries framework. This is also a very interesting work that has been done for a long period of time and is always being updated. According to this framework, these researchers wanted to define the safe operating space for humanity. This is a somehow anthropogenic framework that wanted to show to everyone where is the safe space for, if you want humanity not to be in risk or be at risk, you should be operating in the safe space. You should be in the green space. If you have the red color, you have crossed the boundaries of the planet, the capacity of the planet to integrate, to be resilient, and to deal with these problems that we are creating. And this boundary framework, I don't want to discourage anyone here. This is not to bring bad news. The thing is, it's very important to know the reality, to know where the technology is needed. We need the technology to enable the safe operating space of humanity. That's where we need the solutions right now. And this is not an idea or a philosophical idea. This is not ecological philosophy or spiritual ecology. This is a framework that is also being translated into economic models. You already for sure heard about the circular economy, but now we are talking about the economists, Kate Raworth mainly talk about for the first time about the donut economy, which is a new economic model that takes into consideration the ecological ceiling, so the safe operating space where humanity is able to thrive, and also at the same time solving the inequality problem, putting a foundation, which is a social foundation in which, so the economy should be working in the green donut where there is enough for everyone, but we are not overcrossing the planet boundaries. So this is very important. This is not an academic idea. This is something that it's a transition that should be happening and should happen in this century. I would like. From that idea, it's very easy for you to understand the one perspective. We have the one planet perspective that I already told you. So you are embedded. The humanity is embedded in the planet, and the biosphere is not a backdrop of the human activity. Many times ecologists are seen as the bad guys, the ones that do not allow technology, are against the evolution, the technological evolution. No, we are not. What we try to say is that we are all in the same planet, and it does not make sense that the technology is outside. It's working in an outside objective. And from the one planet perspective, it's very easy to go to the One Health perspective also. If you have a degraded river or stream, the animals, this will not just be a problem, an environmental problem. This will be a public health problem. This will be a zoonosis problem, and also a food security problem. So it's very easy to understand. And I added a new one, which is the idea of one technology. At least I think I added, because I never read anything about it. What I propose and think is that the solution should never try to replace the nature or the ecosystem. It should make nature more possible and not less necessary. And for me, this is the one perspective. And what it's easy to understand the OneAquaHealth, the idea of behind the OneAquaHealth, where we want the harmonious coexistence of a stream that usually you do not see within a city. Many times they are just put aside, or they are underground, or things like that. We would like to see an harmonious coexistence of an urban stream. Because like I told you in the beginning, when I showed you the drainage basin, actually these rivers, they are one of the only ecosystems that have an unidirectional force. It's always running downstream, and they almost act like blood vessels. If you see, they connect the terrestrial environment with the marine environment. So they have a lot of different functions. They serve us and serve other animals. And what we want is an harmonious coexistence. You should see yourself here in this place with your pet and with wild animals and inside the urban scenario, and see how to make these, how to potentiate this, how to make it possible, more possible. This is what is behind, I think this is what is behind this challenge. We go to part 2, where if you are not convinced right now that the planet is intelligent enough, I give you some ideas. First, I consider ecosystems as information processing networks. They integrate signals from entire catchments, as I told you before. It might be raining in the place. There are some different land uses everywhere. There is soil chemistry, temperature. There are different communities, and everything works in the real time. They are all sensors, and they remember. Why? Because the communities, if you, like I told you before, if you go to a place and do a sampling, and you see the organisms that are there, they are the end of a cumulative process. If you see a macroinvertebrate, if you do a kick sample, it's our sample in our official protocol, kick sample to capture the macroinvertebrates, they tell you a story of what happened in the previous months. It's not a snapshot, they are the biography of the system, which is a kind of, they remember, there's some here, there's some wisdom here. And also they respond. Species, everything that is, the species work not just as sensors, but actuators, and the ecosystems respond. If you have fishes and a threat is there, they will go away. If they can move, imagine if they cut the trees, the birds go away. So there are ways to respond to change in the conditions, and they regenerate. And like our machines, if you give the proper conditions to a specific system, they will be able to regenerate. We will have pools of colonizers that will go again and again to that place if he has the conditions for them to live. And this is, in my point of view, planetary intelligence. However, even if you still are not convinced, we have been using many, in a biomimetic way, many inspirations coming from nature itself. There are several examples. One is a train, I hope I'm spelling it right, the Shinkansen bullet train in Japan, which had a problem in the beginning in its engineering conception, because when they were passing through tunnels, there was a boom, a sonic boom that affected all the populations around. And how they solved it was to mimic the beak of a kingfisher, which is that bird there, which dives to fish, and because they eat fishes. He dives, and when he dives, he almost doesn't do any splash because of the form of the beak and, of course, of the body. So they mimic the front of the train like a kingfisher. Another very interesting example is the Eastgate Center, is a shopping in Harare, in Zimbabwe, which, first, they wanted, of course, these kind of constructions. This architecture required a lot of ventilation and things like that. But they inspire themselves in the ant colonies' mounds, which had a structure of ventilation and very proper structure of ventilation that were able to maintain a specific temperature within the mound of the ant. They were able to maintain a temperature, a very stable temperature, so they biomimic that in the architecture of this building, and they were able to actually to have a lower temperature than the temperature that was verified outside. And then we have other things like many algorithms. For example, there are some algorithms in transport and logistics that were based in also how the ant colony moved. For example, imagine that the ant goes from one point to the other. And how does the ant find the shortest path? They will leave a trace of pheromones. And imagine the first ants maybe go random from one point to the other. But as the ants cross those paths, the concentration in the shortest path started to increase. And that's the way, the reason why with time, they will find the shortest path. And we are using those I did this simulation in Anthropic's artificial intelligence. We are using this kind of algorithms to find the shortest path between points. We have, if you want to see more details about what I'm telling you, I have here, but we have other examples. This is also, we have biomimetic examples in aerospace, for example, when the owl moves, because they have feathers with the leading edge that is serrated, they are almost silent. And we are using these serrated patterns in our wind turbines and also in aircrafts to make them more silent. We have been using also these inspirations in medicine. For example, we see that the mussel, they hold to the rocks in very turbulent water. They live on rocky shores, and the water is very turbulent, and they do not they are not removed from there. And we started understanding that they have some adhesions or that are very rich in a specific protein. And we were able to make some sealants that can stick to, can be sealants and used for serological purpose, because they can stick to the tissues, the moist tissues. That's incredible, I guess. And we have another original and another interesting and intelligent being, which is a beetle. And this is a very specific beetle that I remember to study in ecology when I was younger. This is the Namib beetle, which has a pattern of hydrophobic and hydrophilic microsurfaces, and he lives in this desert. There is a very high level of water scarcity, and for him to thrive and be able to drink water, he puts himself like in that position, and when the fog comes, the water will condense in the back part of the body, and then he will drink the water. We did that. We did that too. So these are the originals. These are not metaphors. This is not the way around. Many times we are inspired. We see things, we are curious, we want to know how they work, and we apply it. And nature, so we see that nature have already solved a lot of problems. Here I present you more details about the examples that I gave you. And here is this is an illustration that I did when I was a younger researcher. And what I tried to understand by then was, usually I stand by a river and see the river running. And I wanted the perspective inside the river, what was happening inside the river. And I put myself in the river. what I saw, what I start imagining when seeing is that the river is not just the channel, the moist channel by itself. It is made and composed by a very specific vegetation in the sides. This has to be very specific vegetation because it has to thrive in high moist. Don't forget that when you have plants in your house, you can drown your plant. You should not give it too much water. It depends on the plant, of course. So these are very specific riparian forests, those that live and thrive along the river. And what I saw is that all the organisms in the river are fully adapted to the riparian forests and the terrestrial environment surrounding them. What happens is that many leaves of the trees will fall into the river. Then they will be colonized by bacteria, fungi. Then we have invertebrates that are shredders, and you will break these leaves in smaller parts. And we have other invertebrates that are collectors because they will feed on smaller little particles, and they construct little nets to catch those little those little particles. And everything there's no waste. There's no central command, and no engineer is required. And then we have the predators that will feed on these invertebrates. Some of the invertebrates live most of their lives in the form of larvae and nympha, and then they pass through metamorphosis to the terrestrial environment. And what I started to see is that this is fully connected. Well, and indeed, as I told you before, I started to see the rivers as blood vessels of the terrestrial environment that ultimately will go to the sea, and they connect everything. So for me, this is a planetary intelligence. Everything is integrated, and it's not a metaphor, for sure. Now I want you to become aware of a trap, what I call the surrogate trap. When nature becomes an excuse not to conserve or restore, it's more or less that trap. When we try to use technology, there is very well-intentioned technology, but we want to replace something in nature or some service. This is, for me, very dangerous. With more or less time, you will give yourself, you will be shooting yourself in the foot. Things will go wrong. You should ask yourself, what does the river need to do it itself? Any technology, once again, should be embedded. I have the one technology idea, and the technology is part and embedded in the environment, in the planet, in nature, in life. And if your solution tries to make the stream less necessary, you failed. You are treating the symptom. You are calling the technology as the permanent solution. You are replacing a natural system. With more or less time, things will go wrong. And that's, for me, the surrogate trap. I always have the one technology perspective, and I think that's the true challenge here. I think people which develop technology should place it exactly in this conceptual shift to the reality. Now I have you I put you here another question, and this is a question that I would really like to see answered, but it depends if you want or not to answer. But please question yourself. What part of nature do you think would blow your mind to really understand? And if you want to share it, if you want to, well, you are not obligated to share, but I would like you to share that. What would you really think would inspire you to be better, to build better? Well, I will not give many time for your answer. We can see these in the Q&A session. But please try to, there's no wrong answers here. We can just, this is just a little talk. Once again, I have to be a spoiler because even if you don't recognize it immediately, probably you are already doing it. You are already doing or using things that are built on some astonishing things that are happening in nature. Things like artificial neural network, for example, that have a very strong biomimetic inspiration. But be careful with biomimetic, because biomimetic has to be really biomimetic. They should not be not functionally biomimetic, not just aesthetic biomimetic. And in the case of technology, the technology has really been taken inspiration from many biological systems. This is also the case of some algorithms and machine learning that had an inspiration from DNA and phylogenetic trees as models, and many other things. We cannot. This is a living proof that we are disconnected from nature, but even though we are still inspired by it. Now I have another question for you. And this is the real challenge of this hackathon, I guess, but we can talk about it in the Q&A section. How can the logic of urban stream ecosystem inspire the architecture of OneAquaHealth technology? I think this is really the challenge here. You can share it or not, but stay with this idea. And to answer this question, put yourself in that urban diagram that I show you. Put yourself in a city where a stream runs, and how can you make the stream more possible in that system and improve OneAquaHealth? Well, now we go to part 3, where I'm going against all odds, because our current culture pushes us to build fast, to iterate fast. In my case, is publish or perish, things like that. And what I'm asking you is the opposite. Observe first. The most resilient systems on this planet did not iterate fast, for sure. They take a lot of time to evolve, and they were totally present in the context to evolve. And they've been running without crashes for millions of years. Of course, we are not talking here. Things are still running. We lost dinosaurs, but life itself never lost the planet never lost the link from life. And I know you don't have millions of years, and you don't have a lot of time. You have your lifetime, but still observe. And I'm telling you, this is useful for your work, and this is useful for your life, I guess. And I give you a simple protocol. This is a methodological idea that before you open your laptop, let nature be the first brief, and go somewhere live, sit still for 10 minutes. Try not to use your cell phone. No photos, no notes. Try to leave your cell phone in your house. It's very strange for me that people go to a concert or go to a place, and instead of living the moment, they are video recording everything. Try to be there and experience everything. And you can ask, what problem is nature solving, for example? Look for small things that you usually would not look at. Connect what you see with what you do. And do not visit one place just once, because when you visit a place once, you are creating a snapshot. Even if you are not taking photos, you are creating just a snapshot. If you visit it repeatedly, you are creating a story. And keep a nature notebook. It's not bad. And you can do this in nature. You can do this in society. You can observe wherever you want, but stay there. And this is, for example, one of my places. This is a river that I have near my house, and I visit often, and I see things I love to see. And now we go to the part 4, where I'm saying that from nature go from nature to your project. So you have to be able to stay amazed, to stay porous, curious, and open. And why this is my advice, and I'm trying to use it in my own life. Why? Because many of the greatest discoveries the greatest scientific discoveries were not just inside inspiration. There were some questions in people were curious about. They had particular questions. They are curious about some things, and the inspiration came from a pattern of openness. At some time, the world was signaling, because the world has already created a lot of solutions, but because they were very focused on the question and opened at the same time, they were inspired. And this happened a lot of times against the odds. The scientific creativity. I don't think it's necessarily related with the scientific, the protocol, the guidelines. It's really, the inspiration doesn't just live inside us; it passes through us if we are open to it. And it's just like being a child again, making the right questions, questioning everything. But inside you have an internal dialogue with whatever surrounds you. And this is not a soft suggestion, and it's genuine innovation. And actually, you cannot learn from nature and from any surroundings if you are not being willing to be astonished by it. If you think you already know, you will not learn anything. And the amazement is not the opposite to rigor. It's its beginning, in my point of view. And I think I'm not the only one, because if you go to Silicon Valley, I think they are trying to, because of the creativity, what they call creativity crisis, they are trying to create places. And for example, in Apple Park, they are trying to create places where people can be in touch with the nature and the surroundings, etc. So I'm not the only one thinking like I'm thinking. And so with these, I leave you some resources if you like the subject I'm talking about. They have inspired me through my work. And well, I finish. We can go to the Q&A, questions and answers. But first, of course, give yourself permission to say, I don't know. It's the first step. And you can also ask nature whenever you want. But I will be here for some time to answer to your questions. And with these, can I stop, or do you want me to continue, Alex, with the next slides?
You can stop. We can give opportunity to the audience to ask questions if they have so.
Okay.
Patrick is raising his hand. Patrick, go ahead, please.
No, sorry. Thank you for your presentation. I was trying to applause, but I left the hand.
Okay, no problem. Any questions? You can always ask nature. Indeed, there is a website that was created. It is Ask Nature. And it's very nice. We learn a lot. We learn a lot about things. I learn a lot about many things I never understood. Yeah, Gora, yes.
Yeah, first of all, thank you very much for this very, very fascinating presentation. Really great. Very, very different than what we have used to. So appreciate your talking about this. So at one point at the end, you talked about, especially when you're talking about the hackathon and looking at the OneAquaHealth project. My question is outside OneAquaHealth. That is, OneAquaHealth project was focusing on urban aquatic system. My question is, why not rural aquatic system and its impact from this subject perspective, not the OneAquaHealth project.
Yeah.
But from what you're talking about, should not we include the rural system as well?
Yeah, it should. The problem is that we have a global tendency to have more dense population in cities, and the urban streams are actually the more degraded ones, the ones that need to be cared for. And if we have a pandemic problem like that, it will be very easy to spread in the city, because we are very densely populating cities. Of course, rural areas are very important, but it's and they should be cared too. Many times for you to take care of an urban stream, you have to take care of the upstream. So for you to take care of to restore, for example, if you want to make a restoration project in a city, you also have to take care of the upstream parts, and many of them passes through rural parts, landscapes that many times have for example, very heavy agriculture, land use, may have very or industrial problems. But you always, because the river is a unidirectional system, you cannot only treat a problem in a place. It's always has to be an integrated process. But of course, in the projections for the future is that we will have very densely populated cities, and that the rural areas will be abandoned or invaded by the cities itself. Cities will be bigger and will be disconnected, more and more disconnected in that philosophical sense and from nature. One thing that really scares me is that, for example, the children, sometimes they don't have, there are many children that never had real contact with nature like I did. It's something that worries me. And the only way for them to understand the importance of nature is to see a talk like this, or read a book or something like this, or to have interest in the system, because everything tells him about, if you live, I imagine myself as a child in New York City. You don't have you have a very abstract idea of what is nature and what's the real meaning of nature. It's just something that we don't need, and I don't. That's very dangerous.
I think another reality is the fact that ultimately anything you do, the economy or economics come into play. There's a cost to it, and there's a tendency, obviously, or a need to spend more money on the urban side because of the population density versus on the rural side, right?
Indeed,
And
also.
so that's one of the realities.
Yeah, but actually, yeah, and that's another one. That's another point. But in rural areas, you always have less dense population, human population, and even, well, I'm not sure. Well, I will not answer more than this. I think the river, for you to operate in a river, you have to be very, even in the city, you cannot only just look to the city, because this is a network.
Yeah. Right. And you rightly said there's an upstream.
Yeah.
So the river doesn't suddenly come up in a city. It's coming from somewhere else. So
Yeah.
yes. So thank you. Yeah. Alex,
Thank
all
you.
yours.
Thank you. I have one question also from my side. I think you answered it already through your presentation partially. But based on your work and experience, what are the challenges that a scientist faces when she or he tries to translate biological principles into practical, scalable human technologies? I think
Yeah.
one of the
It's very hard if you don't connect everything. If you don't do it in a way that the society places itself in nature and economy, if you don't connect everything, it will not be possible for you for anyone to understand the importance of planets. And this is an idea that was created probably as I told you before, some hundreds of years ago, when we had to work a lot and machines were taking us a lot of weight of the working load, and we started to disconnect ourselves from nature because we started to have technology, the cars, everything, and it's very difficult for someone to see for example, I had a colleague of mine that did a presentation about microplastics and nanoplastics some years ago. And it was not a catastrophic presentation. It was a very optimistic one. She was giving real solutions to the problems we face with plastics. But one student raised his hand in the end, and he asked what she thought about the possibility of going to another planet. And that was astonishing because for me, because he was already thinking of an escape alternative. And I see that people they do not want to create solutions. If they are ruining this planet, they don't care, and we are transforming into a kind of predatory I don't know, species. We see ourselves as going to another planet without learning what we need to learn here and doing the same. And that scared me a little. So when we talk, we will never talk to everyone, I think. But we have to integrate, we have to give a wide perspective of things. And the shift that Locke and other researchers are doing, the nature positive shift, is very important. People are not used to see themselves nested or embedded in nature. And as humans, we are a creation of the life planet, of the evolution, and our technology is also creation of these systems. It's not outside of them, but we see it many times. We see technology as something outside of the planet and the environment. And this has to change. It has to be step by step. We have to continue doing it. And especially with children. They are more porous, curious, open, and they do the right questions many times. They also bring solutions, which is interesting. So it's just keep doing it. That's the deal.
very much, Sonia, for a really nice and comprehensive answer. Are there any questions, guys, on your side?
If there are no question, maybe I'll ask one more.
Okay.
Just thinking of the hackathon,
Yes.
which this education series is part of, where we are inviting young scientists from around the globe, young at age or young at mind.
Yes, that's my. I hope so.
So all young scientists. So when they look for solutions, the idea of the hackathon is really to unleash your mind and be creative. And in the purview of OneAquaHealth, can they propose a solution? So your point, I really liked your slide where you had a big circle and the technology was central or was embedded in it and was not as a part of three separate entities. So I think that will help our uh, contestant participants to come up with ideas. So I just wanted you to sort of maybe talk a little bit how you see that one technology approach, because as you said, you proposed that as something you have not seen that, and I like it. So talk about the one technology a little more.
What I base myself in what I read, and I was recently in a webinar of nature positive shifts, and I really liked it, and I saw the three circles: the environment, that is based on the L'Oréal 2026, and I really like that nature positive shift and transition. But I immediately, because I see that now the rich fellows are the technologists, the ones that have the millions are the ones that invented the best technologies, and there is a run. There is, for example, in artificial intelligence, we are seeing people running for the best AI product. And I saw that there was one circle that was missing there, which is technology, because it is nowadays very important for the it's one of the drive of the economy right now. And I think we should place for technology not to try, because I know there are some very rich guys that want to go to another planet and would like to do not have the same sensitivity as an ecologist, for example. I would like that people that are developing technologies place themselves exactly in that model, know exactly where they are. It's an important shift. It's really an important shift, and I see the one framework as where technology must be there.
Sure. I think one key point which I think it's may not be clear to people when you talk about one technology, you're really not saying one single technology, but what you're really saying is interconnected technology, but having an impact on the society, on the environment.
Exactly. I don't believe in monopolies. Because in the planet there is no molecule that dominates everything. There is no system that dominates everything. We have different species living in different niches, requiring different things, and they all interconnect. I don't see AI which is mimicking the neuron of a human being, as the most interesting, intelligent thing that we've created. I would like to see an artificial intelligence that mimics the planetary intelligence, and it cannot be just one. They should work as a river and should be interconnected, and they should be able to respond, regenerate, a lot of different things that the planet does. But we don't want to substitute the planet. We want the planet to be possible. Actually, the planet is not at risk. This is important here. The humanity is at risk, like you saw in the boundary, the planetary boundary framework. What they are measuring, and the green part is the safe operating space for humanity, because we are destroying ourselves, and with us, many species will go. We will destroy a lot of species, but life will stay and the planet will stay. So it's very important for us to be in the right place, I guess.
No, I think, yeah, thank you for making this point. Yeah, it's really perfect. And is there any other question from other members? Otherwise, I do see a question, TM. Yes, the whole idea of having this educational session is to have experts like Sonia and others who will be coming and telling us and guiding us about what are the possibilities. So in terms of mentoring the participants. But would love to hear from you if you have any specific question. But as my colleague Alex has mentioned, yeah, definitely we can reach us through the email. But if you have any specific question, please feel free to unmute and ask. All right, thank you for joining. And anybody else? Otherwise, Alex, you may want to continue with the other part of the presentation. Yeah, but first of all, before Alex goes, let's give a big hand to Dr. Sonia Serra.
Oh, thank you.
Nice presentation, sounded great. All right, so moving towards the end of our webinar, we'd like to invite you to visit our Open Information Hub, register for the hackathon. We have already a really good number of participants who have registered to participate in this great event. Please visit our Open Information Hub, which is the main communication channel, that's the project platform, to explore further networking opportunities with our beloved consortium members. Get in touch with us via our Twitter, Facebook, and LinkedIn project channels. We have also launched recently a YouTube channel where we upload all these videos. These videos can be found also on the Open Information Hub. We're planning many more exciting events and webinars, so stay tuned, and we'll be happy if you're again part of them. So thank you very much one more time, and we wish you a nice rest of the day. Thank you.